Good morning, Akshita. In our last class, sorry, it is taking really long time to get time to teach you on YouTube. No worries, but I got a free time right now. I can teach you for a long time. In our last class, we discussed about circle and semicircle. If at all you remember, we discussed their areas and their perimeter. Now we are going to discuss about sector. Okay, what is a sector? If you take a circle, let's call this as center O. Like a circular pizza getting divided into number of parts. This one part, what you are seeing now, this is called sector. This sector will have area and perimeter. Let's name these points A, C, B. Now, first of all, let's talk about length of arc A, C, B. For all this, we need this middle angle. Let's say this angle is theta. So, total perimeter, or otherwise total arc length of circle is nothing but its circumference, this 2 pi r. You know it all, right? R and R. This 2 pi r is there for how much angle? For 360 degrees, cause this total angle is 360 degrees, right? So for total 360 degrees, we have length as 2 pi r. Now, for theta value, how much you will have? Like chocolate, this no, this simple chocolates problem. 10 chocolates are 100 rupees. One chocolate cost is how much? Similar way, we are doing this one. If you see, for 360 degrees, it is 2 pi r. For theta, it is how much? Let's call this as x. So whenever this kind of case comes, we do cross multiplication. X into 360 is equal to theta into 2 pi r. We need x value. Therefore, x equal to theta by 360 into 2 pi r. Very simple to remember this formula. Theta by 360 gives you fraction and 2 pi r total circumference, total perimeter or circumference. So your formula is nothing but the arc length is equal to some fraction of the total circumference. That's it. You can easily remember now. So yeah, if you see carefully here, total length 2 pi r. For 360 degrees how much? For theta how much? Okay, this is length of arc, nothing any connection with the sector. When it comes to sector, they will ask you about area. That we will do it. Please note down. Next page I'm going. I'm going for the next. Area of a sector. Similarly, like how we have calculated the length of arc, similarly we calculate even area of sector. So for 360 degrees complete rotation, what is the area you will be getting? Nothing but total area of circle, that is pi r square. So for theta, how much it is? Let's call it y. Cross multiplication. Y into 360 is equal to theta into pi r square. So y will be equal to theta by 360 into pi r square. Here also same analogy will work. This is the fraction and this is the total area of circle. So your area of sector is fraction of the total area. Please note down. I'm going ahead. Now, one more last thing about the sector, that is perimeter of a sector. We have seen length of arc, not the perimeter of sector initially. Now we are seeing perimeter of sector. See, this is how your sector will be there, OA, CB, right? So this is radius. If you want perimeter is nothing but OA plus ACB arc length plus OB. Here OA and OB both are radii, so R plus R 2R, and now arc length ACB is left out. That we already found. Theta by 360 into 2 pi r. So this is the formula, nothing else. Okay, I'm going ahead, Akshita. Now in this thing we learn three things: length of arc, area of sector, and then perimeter of sector. So length of arc formula is theta by 360 into total length. area of sector, same, theta by 360 into total area. Perimeter of sector is 2 times radius, that OA and OB, plus length of arc. These are the three things we learned in concept called sector. Okay, now if you want, you can all of them, you can write it at one place and then nicely box them. That will give you good clarity whenever you want to see formulae. It's not about formulae, it's about understanding. If once you understand, you need not remember this, automatically it comes to your mind. Now next kind of figure is segment. That's not given in your textbook. I'll just show you what is that segment. That will be like, if at all it's coming in your textbook, I will deal more in depth. This is center. Okay, now this is called AV, is called chord. Now this area under AV is called segment. So now here, if you see carefully, AB chord, okay, tap is leaking. Tap is leaking. I'll just off it. Yeah. Thank you for giving the time. If you see carefully here, the line AB divides the circle into two parts. The parts are, I'll show you with the ink. That will be more good. You'll like it. Yeah. Okay, now if you see in the diagram, one is blue color part, one is green color part. This blue color part is a smaller area, so this is called minor segment, and green color part is of major area. This is called major segment. Even for this segments, we can find perimeter, we can find area. So if it comes in your textbook about these segments, I will surely teach you. Sir, why to wait for coming in textbook? Let's learn it, Akshita. As a mathematics people, we should know what is the formula for their area and how to do that. Please write down till here. I will go ahead to show you how to derive the formula for area of. Let's deal with the minor segment, then it's very simple about the major. Same formula will be there. Okay, I'm going ahead to find the formula for area. I need this diagram. Huh. So let's erase this one. Let's say this is the center of circle. Why it's not visible? Yeah, this is radius, and this is angle theta. Now we need that blue color area, right? So blue color, blue area is nothing but see carefully, sector OAB area minus triangle OAB area. Whether you're getting this or not, I'm not sure. Okay, let's say yeah, I think, sir, see carefully, I will just try to show you with the red coloring. If you want the total blue color area, what I am doing is this total area, this I am calling it as sector OAB area minus I am removing this triangle area. If I remove that OAB triangle area, the down part I will be getting that blue color area. That's what I have written there. So here the sector area, just now you have calculated how much? Theta by 360 into pi r square. Before only we calculated, because theta angle, that is sector area. Good. Minus triangle area. How do we calculate? It's a big problem. How can we calculate triangle area? Okay. There is a formula for the triangle area, Akshita. How that formula will get derived, I will show you. But first I am writing that formula. Half r square okay, forgot. No, it's not half r square, Akshita. I will derive it right now. Minus triangle area. Please write down like this. Triangle area I will derive in the next slide. Please write down like this. I will derive the triangle area in the next slide. Okay, I'm going ahead. This is how you have it, right? O, A, B, R, R, and theta. Correct, na? So how do we really find this? So what we're going to do is, we are going to drop a height. Call this point as C. This is 90, this is 90. And this is isosceles triangle. Therefore, this angle will become half of theta, and this angle also will become half of theta. Correct? And now this length will become height of the triangle. Fine. Now little bit trigonometry, you know it, right? I'm going to use that. In triangle OBC, see triangle OBC, OB is hypotenuse, angle C is 90 degrees. So what I'm going to do, I'm going to calculate sin theta by 2. Theta by 2 is this angle. Sin theta by 2 is this opposite side, let's call it x. Sin theta by 2 opposite side x by hypotenuse r. Therefore x value will be r sin theta by 2. Okay. Now if at all any doubt, Akshita, please WhatsApp me after the class. Sir, this concept I did not understand, how to find area of triangle or anything. I'll take care of about that. Okay, I'll reply you. Now Akshita, not only this part is x, even this part will also be x only, right? Therefore I want 2x value, that is nothing but the total base length of the triangle AB, that is 2r sin theta by 2. I think it should be clear till here. Any doubt? 2r sin theta by 2. Now area of triangle, area will become half into base, that is AB, into height. We did not find height yet. Okay, we did not find the height. We will do that. Okay, first we will do that and then we'll come back to this. How do we find the height? We can use another trigonometric ratio, that is cos theta by 2 in the same triangle is adjacent side h divided by hypotenuse r. Clear? Any doubt? See carefully. Adjacent side h by hypotenuse r, which implies the h value is r cos theta by 2. R cos theta by 2. We got the base length AB, we got the height h. Okay, please note down. Slowly write down. If it's completed, I'm going ahead, Akshita. Please pause the video if it's still not completed. Now, so the same triangle O AB, and we have a height, right? Yeah, we got the height value as r cos theta by 2, and we got the base length AB, nothing but 2x, as 2r sin theta by 2, right? Therefore area will become half into h into AB, half into r cos theta by 2 into 2r sin theta by 2. So half into 2 r's are there, right? R square into, I'm going to put 2 sin theta by 2 into cos theta by 2. See carefully, 2 sin theta by 2 into cos theta by 2. Yeah. Uh, yeah. One second, Akshita. Yeah. Now it will be half into r square into, in trigonometry the formula is there, that is 2 sin theta by 2 into cos theta by 2 is nothing but sin theta. Finally, area of the triangle is equal to half r square sin theta. This is an important formula. In future it will help you a lot, Akshita. Please make a note of it. Very, very important. So if you go back, here we have written triangle area na? In this place we can write this as half r square sin theta. Now you will be getting that segment area. I hope so. This is very much clear to you. We have completed. Okay, let me go back so that you can write it. Okay, Akshita, I'm ending the class over here. We will continue this in the next class. Thank you.